Okay, we're on topic number 4, which is angle addition postulate. Go ahead and pause this so that way you can copy everything down. By the end of the notes today, your notes should look like this. So it's 3 vocabulary words. Actually, the last one's up there, a postulate, but 2 vocabulary words, one postulate, and then 2 examples on the bottom. So go ahead and copy what you need to copy. Press pause on the video if you need to. I'm just going to go ahead and get started on this. So angle addition postulate, we're going to start off with the fact that all angles are based off of a portion of a circle, and a full circle is equal to 360 degrees. So I'm going to go ahead and highlight that. You're going to need 3 highlighters for the lesson today. A full circle is equal to 360 degrees. So if I were to get a full circle, like let's say I have this line right here, okay, and it starts here, and then I would take that line, or I'm sorry, that ray, and go all the way around. This would be a full 360 degrees to go all the way around from the center of that circle. If I were to go only halfway and have the ray end up here, since I only went halfway, then I'm only going to go half of that 360, which means this is going to be 180 degrees. Now, why is that important? That's important because if I get rid of that little half circle right there, that makes a line, okay? And so essentially what we're saying is that every single line has a measure of 180 degrees because it goes halfway around, not the full way around like the way a circle does. And then if I were to go half of this and only go halfway, I would end up with rays that look like this. This would be 90 degrees because it's half of the 180. And for 90 degrees, we always write it with a little square right there. Okay, so just a little crash course on why degree measures are the way they are. We go off a full circle, which is 360. Halfway around would be a straight line, would be 180. And then half of the half would be like 1/4 of a circle, or that right angle that we have down there, which is the 90 degrees. Okay, so straight angles are angles formed by opposite rays. They measure 180 degrees. That's the example that we just showed right now. So I'm going to go ahead and draw this in like this, and draw it going the other way like this. I'm going to have points A, B, and C. And again, just like in the picture that we had over there, I'm going to go ahead and draw that in. And notice that this is a half circle, which means it's going to be 360 divided by 2, which means it's going to be 180 degrees. As far as the notation, I want you to know that that is an angle. It's a flat angle, which we call a straight angle. So I'm going to go ahead and say angle ABC measures 180 degrees. As far as what's important to note here, I'm going to go ahead and highlight straight angles measure 180. All right, let's keep going. The next segment, the next definition says an angle bisector is the ray slash line that lies in the interior of the angle and divides the angle into 2 equal parts. So we're going to go ahead and draw an angle. And I'm going to go ahead and put points A, B, and C. I think in class I used different points, but it's not going to matter. The concept is going to be the same. So here's my angle ABC. And now that I have that angle, I don't have an angle bisector yet. I need an angle bisector to be like right smack in the middle in such a way that it's going to split that angle perfectly in half. So I'm going to go ahead and put a dot right there and a ray that goes through it. I'm going to go ahead and call this D. Now, that ray BD that I just drew, it was constructed in such a way that it splits it perfectly. So I'm going to put a double tick mark here. And I'm going to put a double tick mark here. Those double tick marks, or double arcs, I should say, indicate that those angle measurements are exactly the same. So angle ABD and angle DBC are exactly the same. Angle ABD is the exact same thing as angle DBC. So if I tell you that this is 30 degrees up here, then it should match on the bottom. Okay? So what can I say? I can say that ray BD is the angle bisector of angle ABC. And since angle ABD is equal to angle DBC, Then I know that angle ABD was 30 degrees, which makes angle DBC 30 degrees. Essentially, what's happening right there is they said that this angle is the same thing as this angle. Therefore, these 30 degrees must be the same thing as the 30 degrees down here. And as far as what we're going to highlight in our notes, we're going to go ahead and highlight the angle bisector divides this into two equal parts. All right, and then the last thing as far as the definitions are concerned, this is actually not a definition, but it is a postulate. It says the angle addition postulate states that if B is in the interior of angle AOC, then angle AOB plus angle BOC equals angle AOC. That sounds very complicated. It's honestly not that bad. It's something that you probably intuitively already know. We just need to put it in mathematical terms. So I'm going to go ahead and draw a big angle right here. Make it pretty open, almost to 90 degrees. We're going to make it large. I'm going to go ahead and give this a name. So this is going to be A, this is going to be O, and this is going to be C. So here's this big angle, angle AOC. And I'm going to go ahead and make sure that I get B in the interior meaning on the inside of angle AOC. So I need B to be somewhere in here. Don't put it in the middle. Let's make it kind of extreme. Let's put it somewhere down here on the bottom. So that way it's actually not in the middle. And this makes it so that ray OB that I just drew is definitely not the angle bisector, because this angle for sure is bigger than this angle. Again, an angle bisector makes it so that the two parts are equal, and this is definitely not equal. So ray OB is not an angle bisector. In fact, I'm going to go ahead and give you some numbers. I'm going to say that this angle up on the top is 32 degrees, and this angle down here is 10 degrees. Okay, the way this postulate goes, actually, before I even go into the postulate, let's just look at those angles. I have this little angle right here is 32 degrees. I have this other angle right here is 10 degrees. Now I know intuitively that some of you guys are going to be able to see that and come up with a conclusion. Like right away, we should know how much this big angle is, even though they didn't tell us. It's just going to be the summation of 32 degrees plus 10 degrees. It's going to be 42 degrees total. Because if I open it 10 degrees and I open it 32 degrees more, it should be 42 degrees in total. So the way I want to draw this, the way I want to go ahead and start stating this is you're going to add up the two little angles. This first angle here, we're going to give it a name. And I'm going to add it to this angle here. And I'm going to give it a name. And then I'm going to say, well, those two angles put together is equal to the entire angle put together. So for the first angle, the one up here, I need to give it a name. I'm going to go ahead and call it angle AOB. Angle AOB plus. The other little angle is this one. Whoops. I need to give it a name. This is going to be angle BOC. Is equal to the large angle put together, which is angle AOC. Now that I have this, let me go ahead and highlight these sections. Let's see. Angle AOB is this one. And I know that this is 32 degrees. So right here, I can write that this is 32 degrees. Angle BOC, that's this little one down here. And I know that that one is equal to 10 degrees. So I'm going to write plus 10 degrees is equal to angle AOC. That's this angle put together. So I'm going to go ahead and draw it put together like this. But they didn't tell me anything of that one. So on that one, instead of putting a number on it, I'm just going to rewrite it because, again, I don't know anything about it. It's going to be angle AOC. Now that I have this set up, I can just go ahead and it's telling me to add these two numbers right here. I'm going to add the 32 plus the 10, and I get 42 degrees is equal to angle AOC, which is exactly what we thought of earlier, right? Like we kind of intuitively know it was going to be 42 degrees, but here we're doing it with the actual formula. I know what some of you guys are thinking. It's just like, oh, why don't I just order, or why didn't I just add the 32 and the 10? Essentially, why didn't I just do this? Why did I have to write this? My answer is going to be because later on, the problems are going to be way harder and you're not going to be able to do it in your head. And so what you want to do is you want to be able to set up a formula every single time where you just plug in the stuff and it just works out for you, okay? And even with me saying that, some of you guys are still going to want to do it and you're going to get stuck like on round number 5 on today's homework. All right. Let's take a look at the last stuff. Again, this is going to finish up our notes for today. These are going to be the notes for tomorrow. But for today, we're going to focus on just these last two examples. It says, example one, if angle ABD is equal to 48 degrees and angle DBC is equal to 78 degrees, find angle ABC. So I noticed that I have three angles, right? I have this angle on the left, I have this angle on the right, and then I got this large angle that's the two angles put together. So those are the three angles that I'm working with. I'm going to add the two little angles. So I need to give them names. The first one is going to be this one. I'm going to call it angle ABD. That's the first little one. Plus, always add the two little ones. So the second little one is this one. This is going to be angle DBC is equal to, and it's going to be equal to the big angle overall, which in this case is going to be angle ABC. Now that I have this, I'm going to backtrack and try to see what they gave me. Okay, so let's see. This first little angle right here, we said that this was angle ABD. Angle ABD is this one. I'm going to say angle ABD. Did they tell me anything about angle ABD? They sure did. They told me that angle ABD is equal to 48 degrees. So here I get to write it's 48 degrees. Here I get to write it's 48 degrees. Plus, now I'm going to go ahead and look at the other angle. The other angle was angle DBC. Angle DBC is this section right here, and I'm going to check, okay, did they tell me anything about angle DBC? And they sure did. They said angle DBC was 78 degrees. So right here, I get to write that this was 78 degrees. I get to also put in my picture that this is 78 degrees. Equals. And then the last thing I need to figure out is angle ABC. Did they tell me anything about angle ABC? They did not tell me anything about angle ABC. And on my picture, I would draw it like this, but there's nothing to write because they didn't give me any information. So instead of writing a number, I'm just going to write angle ABC. All right, my formula is done. I've substituted my values, and according to that formula, it looks like I should just be adding those two numbers. And I believe, and I add those up, I'm going to get 126 degrees is equal to angle ABC. When I asked myself, did I answer the question? The question was for angle ABC, and I sure did find angle ABC. It's 126, so it looks like I am done. All right, I got one more problem. It says example two, if the measurement of angle DBC is 74 degrees and the measurement of angle ABC is 119 degrees, find the measurement of angle ABD. We're going to do the exact same process. I'm going to go a little bit faster this time. Remember, always, always, always add the two little angles. So the first little angle is this one. I'm going to call it angle ABD. Angle ABD, they did not tell me anything about it. So I'm going to write angle ABD plus. And they didn't tell me anything about angle ABD, so I think I'm just going to have to leave that one as is. But that is my first little angle. The second little angle is this one. I'm going to go ahead and call it angle DBC. Angle DBC is this one. They did tell me that angle DBC was 74 degrees. So right here, remember you always add up the two little angles. I get to write that angle DBC is actually 74 degrees. Over here, they didn't tell me anything, so I'm just going to bring it down. Equals. Equals. The last thing I need to worry about is the largest angle. Oh, I forgot to write it on my picture, guys. Sorry. This is 74 degrees right here. All right, and then the last one is the big angle. This big angle, I'm going to call angle ABC. So over here, we're going to put angle ABC. Did they tell me anything about angle ABC? They sure did. They told me that angle ABC was 119 degrees. So right here, for all of this, I get to put that this is 119 degrees, which means over here, I get to write that this is 119 degrees. Now on the last one, if you notice, they told me I need to add these up. On this one, I have angle ABD plus 74 equals 119. It's not telling me to add up the angles. In fact, I'm trying to get angle ABD, and right now what's in its way is that plus 74. I need to get rid of that plus 74 so that ABD is by itself. I'm going to get rid of that plus 74, and in this case, I'm actually going to subtract 74 degrees from both sides. These cancel, and I get angle ABD is equal to 45 degrees. And that makes sense because if I go over here and I put the 45, then 45 plus 74 does give me the 119 total. So very important that you set up your equations. And then from there, you just substitute your numbers and it'll tell you whether you need to add or subtract. There's really not much thinking involved. All right, that's all I have for today. By the end of today, your notes should look just like this. And if you have any questions, as always, feel free to ask.